All right, here's example 2.24. We're asked to find a point of intersection algebraically. Wow, okay. So here's one line here and here's another line here. And you're asked, where do they cross? And I guess you could graph them and see where they cross, but it does say algebraically, so what this problem has in mind is to do it without drawing the picture. Although we could draw the picture to check our answer. So how do you do this? Well, if 2 points are crossing, at that instant that they cross, they're at the exact same point. If they're at the exact same point, they must have the exact same height. So here is the height of h of t, and here is the height of j of t. And at that point where they cross, those two things must be equal. If this equals this, and this equals this, and this equals this, then this must equal this. In other words, if h of t equals j of t, then 3t minus 4 must be equal to 5 minus t. So what? What does that tell me? Well, this gives me an equation that only has one variable, the letter t. So I can isolate that variable. I can solve this thing for t. Maybe add 1t to both sides of the equation, and then add 4 to both sides of the equation, and then divide by 4, and get t equals 9/4. But wait, what did I just figure out there? Remember, where this came about was by setting these two equal together. I said the heights are the same somewhere. They're the same when this equals this. And algebraically, I was able to figure out that if the heights are the same, the x-coordinate, or t in this case, must be 9/4. So at this point of intersection, when they have the exact same height, the x-coordinate is 9/4. But it wants the point of intersection, it wants the x-coordinate and the y-coordinate. So how am I going to figure that out? We'll take this and plug it back in. Where? Doesn't matter. Doesn't matter. You can plug it in here or here, because the way I found this point is by finding the x-coordinate where these two things have the exact same height. So if you plug it in here or plug it in here, you're going to get the exact same height because that's where this thing came from. So all you got to do is figure out which of these is easier to plug 9/4 into. Probably this guy, but really you could do either one. You could check your answer. You could say j of 9/4 is 5 minus 9/4. If you're a fractional kind of person, you could say this is 20/4 minus 9/4, and that's 11/4. If you preferred fractions, you could have gotten the same answers using fractions. We're done at this point. I could say they intersect at 9/4, 11/4. And if you're confident in your algebraic skills, you're good here. You're moving on. If you're not, you could check your answer. How could you check it? Well, if I plug 9/4 into h, better get the same answer, because where this came from was by setting these two equal to each other, finding the x-coordinate that gives me the same height no matter which one I look at. So I better get the same height coming out of this one that I did here. Let's see if I do. 3 times 9/4 minus 4. Well, that's 27/4 minus 16/4. 27/4 because you can think about this 3 as 3 over 1. And 3 times 9 is 27, and 1 times 4 is 4. And then 16/4 here to get a common denominator. Instead of 4 over 1, you multiply the top and the bottom by 4 to make it 16 over 4. And now that I have a common denominator, 27 minus 16 is 11. Hey, look at that, same height. Looks like I didn't screw anything up. This point, in fact, is the point of intersection between these two lines here. You could try to graph these to check your answer. I don't know, maybe this is a bit overkill, but I'll do it real quick. First, note that you're not going to be able to check your answer very well because these are all fractional, and you've seen how terrible my graphs are. We won't be able to get anything precise, but we can check it for reasonableness. 5 minus t, you could think about this as negative 1t plus 5. So the y-intercept is at 5, and the slope is negative 1. So I go down 1 every time I go over 1. You end up with a graph that looks something like this for j of t. And for h of t, I got 3t minus 4, so the y-intercept is negative 4, and the slope is 3. So I go up 3 every time I go over 1, up 3 over 1, and I get a line that looks something like this. What is this? H of t. This point right here, I can't tell what it is. Can't tell exactly what it is, but would you buy that it's about 9/4, 11/4? I don't know. Okay, what if I told you that 9/4 was 2 1/4, and 11/4 is 2 3/4? Could you imagine a world in which this point right here had a x coordinate slightly more than 2 and a y coordinate slightly less than 3? Yeah, it looks reasonable. Right? It's certainly possible. If I got some negatives over here, or if this intersected over in this quadrant or something, I might question my answer. But it looks reasonable. You can graph this for a reasonableness check. I don't know that you had to do that, so I'll stop here.